Okay, class, we're starting section 1.7, an introduction to problem solving. Section A, solving problems involving addition, subtraction, multiplication, or division. In this section, we decide which operation to perform in order to solve a problem. Don't forget the key words and phrases that help indicate which operation to use. Some of these are listed below and were introduced earlier in the chapter. Also included are several words and phrases that translate to the symbol equal. Now we have our addition, subtraction, multiplication, division, and equality or equal words that we need to pay close attention to. You can look at these words at your leisure. Okay, now in addition to recognizing the terms above, it is important that you familiarize yourself with the problem solving steps listed below. Now, number one, we have to understand the problem. Some ways of doing this are to read and reread the problem, construct a drawing, and look for keywords to identify an operation. Number two, translate the problem. That is, write the problem in short form using words, and then translate to numbers and symbols. Number three, solve the problem. It is helpful to estimate the solution by rounding, then carry out the indicated operation from step 2. And finally, number 4, interpret the results. Check the proposed solution and the stated problem and state your conclusions. Write your results with the correct units attached. Now we're going to take this and apply it. Note, there could be more than one operation used when solving word problems. Now, let's look at example set A. It says solve. 4 friends decided to go into business as equal partners. After their first year, they made a profit of $65,000 after expenses and taxes. If each person receives the same amount of money, how much does each person receive? Now, they went in as equal partners, and it's 4 of them. They made $65,000, and they want all of them to get the same amount of money. So of course we would take 4 into 65,000. This is a division problem. So we take 4 into 6, which goes 1 time. So 6 minus 4 is 2, and bring down our 5. 4 goes into 25 6 times. 6 times 4 is 24. 25 minus 24 is 1. You bring down this 0 here. 4 goes into 10 twice. So now we have 10 minus 8 is 2. And you bring down your next 0. 4 goes into 20 5 times. And now 4 goes into 0 0 times, and you have no remainder. So your final answer here will be each partner receives $16,250. And that is your final answer. Okay, now we scroll down to problem number 2. It says the director of the Learning Lab also needs to include in the budget a line for 425 blank CDs at a cost of $4 each. What is this total cost for the blank CDs? So we have 425 CDs at $4 each. So we have to multiply. 4 times 5 is 20. Bring down your 0, carry your 2. 4 times 2 is 8, plus 2 is 10. Bring down your 0, carry your 1. 4 times 4 is 16, plus 1 is 17. So remember, this is $1,700. So the total cost for the CDs is $1,700. And that is your final answer. Now we scroll down to number 3. It says a college student has $950 in an account. She spends $205 from the account on books and then deposits $300 in the account. How much money is now in the account? Now we would take $950 minus the amount that she spent, which is $205. Now we know we cannot subtract 5 from 0, so we borrow 1 from the 5. That makes that 4, and then 0 becomes 10. 10 minus 5 is 5, 4 minus 0 is 4, and 9 minus 2 is 7. So that's $745. But then she deposits $300 in her account. So now we have to add $300. So this would be 5, 4. So this will end up being $1,045. It says how much money is now in the account. She has $1,045 in her account. That's it. Now, that is it from section 1.7. Now we're going to start section 1.8. 1.8 is exponents, square roots, and order of operations. Section A, exponents. We use exponents as shorthand for repeated multiplication. In exponent notation, the base is the number that is raised to a power. The power is called the exponent. Now this 5 is your base. This 8 is the exponent. So now, let's fill in the chart below. Now what I did, I took the liberty of putting in the word names for these situations. Now, we have repeated multiplication. We have 2 multiplied by itself 5 times. So our base is 2, and our exponent is 5. So we have 2 to the 5th power. Now the value. We have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So our answer here is 32. And our words is 2 to the 5th power. This 2 is taken to the 5th power. Now here we have 3 multiplied by itself 4 times. So that would be 3 to the 4th power. Now for some reason this is shifting. So what I'm going to do, I'm going to write the 3 to the 4th power on the outside. That's what should go for the expression. So now in words it's 3 to the 4th power, and then our value, 3 times 3 is 9, times 3 is 27, times 3 is 81. Now I'm going to write the 81 on the outside because it's been shifting. Now we come down here. We have 8 to the 2nd power, which is 8 to the 2nd power, or 8 squared. Now we want to write the repeated multiplication. Now let me see if I could do this. It'll be 8 times 8. So that took care of the repeated multiplication. 8 times 8 is 64. So that is our final answer. That is the value. Now we have 6 cubed, or I could have written 6 to the 3rd power. Now in this box here, we should have 6 multiplied by itself 3 times. I'm going to write it over here, and it will go for this blank here. So it'll be 6 times 6 times 6. Now this goes here. Now we multiply. 6 times 6 is 36, times 6 is 216. Now this 216, I'm going to see if I can write it here. Okay, this is 216. Now, down here we have 4 to the 4th power. So I'm going to write it here, and you know it goes in this box here. So we'll write 4 times 4 times 4 times 4. Now we're going to multiply. 4 times 4 is 16, times 4 is 64, times 4 is 256. So this will give us 256. Okay, now we filled in the box. Now we come down here. It says caution. Don't confuse regular multiplication with finding a power. We know 5 times 3 is 15. 5 to the third power is 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. There's a big difference. Now we scroll down to section B. It says evaluating square roots. A square root of a number is one of two identical factors of the number. Example, we could do the square root of, let's take 144. The square root of 144, we know 12 times 12 is 144. So the square root of 144 is 12. Now we have another example here. We have 7 times 7 is 49. So a square root of 49 is 7. We use this symbol here, the square root symbol, called a radical sign, for finding square roots. Since 7 times 7 is 49, then the square root of 49 is 7. So we're asking ourselves, what number times itself will give us the number under the radical? We know 7 times itself is 49. So let's scroll down here. We have the square root of 100. What number times itself will give you 100? It's 10. Square root of 1. What number times itself is 1? We know it's 1. Now for 81, what number times itself will give you 81? That's 9. And what number times itself will give you 0? And we know that's 0. Now, we scroll down here to order of operations. If there were no rules about what to do first, what two answers could you get? So if it was no rules, we could go left or right. 5 plus 6 is 11 times 4, which is 44. Now, since we're not operating on rules, let's just say we did the multiplication first. So we'll say 5 plus 24, because 6 times 4 is 24. 5 plus 24 is 29. Now these are two drastically different answers. So let's go down here and learn the order of operations. Now, many people use the mnemonic device PEMDAS to remember the order of operations. The P stands for parentheses, E is exponents, the M is multiply, the D is divide, A is add, and S is subtract. Now, this is the first step you do, which is parentheses. The second step is exponents. And the third step, this is where many people get confused. Multiplication and division has the same rank. It's whichever one of them appears from left to right that you would do first. And the same for addition and subtraction, which is the last order of operation you would do. So again, it's parentheses first, then exponents. Then you could do multiplication or division, whichever one comes first from left to right, and then add or subtract, whichever one comes first from left to right. So we have these hints here. It says here, hint 1, do one step at a time. Consider using the method of boxing in the operation to be performed next at each step. Number 2, if there are several sets of grouping symbols, start from the inside and work your way out. At any step, you should always be working on the innermost set of grouping symbols. Step 3 is once you have reduced what is inside a set of grouping symbols to a single number, stop writing the grouping symbols unless they are needed as a separator. Based on the order of operations, which was the correct way to do the earlier example? Now we see that multiplication comes before addition. So we will multiply first, so it'll be 5 plus 24, which we know is 29. So that was the correct answer to that problem. Now we go here to example set B. Now we have addition, we have an exponent, we have multiplication. Now we know first is parentheses, then we do the exponents. So we do 3 to the second power, which gives us 9. Now we're left with addition and multiplication. We know we do multiplication first. So we had 8 plus 54. And 8 plus 54 we know is 62. So we're done with this problem.